Thanks for the intro. It's nice to be here. Like you said, I'm a professor at UNC Chapel Hill, and I also am CTO of Shopagon Inc. This talk is really about the work on the academic side at UNC. My group mainly works on recognition in computer vision, so this is kind of a wide stab. But as I just mentioned, one of our projects was this ImageNet challenge. And this is work from 2010 through 2017 with Fei-Fei Li's group at Stanford, well, Princeton and then Stanford. And one of the funny artifacts is that, we collected this big data set, we released a challenge, and it sort of coincided with some of the advances in GPUs and neural nets. And so together we got this, really rapid advance in computer vision systems. But almost all of the baseline networks we see, it's like I go down and I see demos of various networks running on embedded devices, which is amazingly cool to see. But a lot of them were pre-trained on this ImageNet data set. So at the same time, when people show like the silly things that networks mistake, or the things they get confused by, part of that is artifacts of the network architecture, and part of that is artifacts of the data that was trained on. So I feel some responsibility on that side too. More recently, I've worked with a professor at Purdue on the low power image recognition challenge. This is basically taking the ImageNet style tasks and plugging in a power meter. So you can measure things like the mean average precision, the accuracy of a detector divided by how many watts it uses. So MAP per watt. In the past, we held this at DAC, and more recently, we've been holding it at CVPR. Also on the research side, I work on problems like recognition and detection. So our single-shot detector was a relatively fast and accurate detector. This came out in 2016. And this was really making detection closer to the computational cost of image classification. So before that, detection was relatively expensive. You would not run detection on 1 billion images for general object categories. You might do it for faces, for cars, for specific categories. Doing it for general object categories really came sort of after some of these fast detection techniques around 2016. And so I'll talk a little bit more about SSD and some of its successors now.